Hello students, so very good morning. In today class, we are exclusively, as I told already, we are completely going to discuss physical chemistry. So the first thing all the students will ask, sir, the session time. So the session is of about 2.5 to 3 hours duration. So in that duration, I will try my level best to complete the entire physical chemistry of Yes, class 11th as well as 12th class. So, is everyone else ready? So, before that, Robin, Ammadi, HV1, yeah, Ananya, Subashri, Farzana, Mohammed, a very good morning, my dear students. So, now shall we get into the session? Okay, before getting into today class, I just want to know only one thing from you, my dear students. Tell me honestly, the last two marathons of chemistry, if you look at the timing, it is of around 10 hours duration. I completed the organic chemistry part of class 11th as well as class 12th. Now when it comes to this particular topic, physical chemistry, how exactly I'm going to approach means, first, what are the physical chemistry topic we are having in our syllabus? If I talk about class 11th and then class 12, the first physical chemistry topic from class 11, what is the first physical chemistry topic we are having is atomic structure. Yes, the first physical chemistry topic what we are having is atomic structure. Followed by atomic structure, periodic table, and then all those things, chemical bonding, everything will come under inorganic chemistry. Low confidence for physical chemistry. No, it will be very easy. Listen to class. My class is all about strategical approach. No need to read everything. So listen carefully. Atomic structure followed by mole concept. That is basic concept of chemistry. Basic concepts of chemistry. Then if I talk about equilibrium, followed by thermodynamics, then redox reaction. From class 11, we are having only these 5 topics. So we are having, hi sir, hi Henry, very good morning. So these 5 topics we are having from class 11. If I talk about class 12 chemistry, if we talk about class 12 chemistry, the first chapter is solution. Next, followed by that, electrochemistry. Then the last one is chemical kinetics. Since we are running out of time, honestly speaking, we are having less than 10 days actually time. Right, today is 25th. Then May 3rd is our examination. Then you guys can able to calculate. Approximately, we are having only a week time. Now tell me, in this week time, if I start explaining each and everything, do you guys think it is possible? It will be very tough. So organic chemistry, yeah, out of 60, if those two marathon, if you people would have listened, easily each and every one of you can able to score 45 plus. Because A to Z, everything I discussed in organic chemistry. Yeah, only 6 days we are having. Now, for this, what is the approach? I just want to tell you, my dear students, no need to read everything. Don't break your head by reading everything. Very simple. If I talk about NEET paper, we know total marks in chemistry is 180 marks. In that, for sure, 60 marks will come from inorganic chemistry, 60 marks from physical chemistry, 60 marks from organic chemistry. Yes, are you? Good morning. Oh, why this much actually? Yeah, so very happy morning. Now, we know very well from 60 marks we will get from physical chemistry. To ask the 60 marks from physical chemistry, how many questions is required? The question paper need to ask only 15 question, right? Only 15 question we will get from physical chemistry. Now, how many chapters we are having? 5 plus 3, 8 chapters we are having. So, minimum if I keep 2 question from these chapter, minimum 2 question, easily we can able to attempt all 15 question. Now tell me one thing, even Ambika ma'am will be always telling this, even Subrat sir also will be telling this. When it comes to NEET examination, 50% of syllabus is biology. 50% of syllabus is biology. So in these last 7 to 8 days, the crucial part is again and again we need to revise the biology part. Honestly, I'm telling, if you guys can able to score 350 plus in biology, then chemistry, physics together, if you score 260 also, easily you guys can able to get the medical seat, because score will be almost near to 600. Yeah, you will be getting GMC. But the problem is to score the 240 or 260 mark, we are struggling a lot. So in chemistry, 150, 160, if you score, that is more than sufficient. So my strategy is, what are all the topics you guys must need to do means, don't miss the chapter of atomic structure. Because in atomic structure, you guys can expect minimum 2 question. If the question paper setter is very good, you guys can expect even 3 questions also. So minimum 2 question, it is guaranteed from atomic structure. For to get those 2 questions, what are the concepts, everything I am going to tell, listen carefully. Apart from that, don't miss the redox reaction chapter. Short, one question is confirmed from redox. One question is confirmed from redox reaction. So definitely you people will get one question from redox reaction. Then equilibrium, sir. Equilibrium is very tough, sir. I don't know how to calculate pH. That's why, my dear students, throw that off. But we will be getting one question based on KPKC or Lee-Chattier principle. Am I right? Whoever the question paper setter, definitely short we will be getting one question from KPKC, equilibrium constant. Now, thermodynamics. Sir, it is very tough, sir, thermodynamics. No, my dear students. In thermodynamics, do only one thing. Basic terminology you guys read. Definitely you guys will get one question. Basic terminologies. Now I will write. In atomic structure, what are the points you guys need to focus? In equilibrium, what? Thermodynamics, what? Redox, what? Apart from this, basic concept of chemistry, solution, electrochemistry, chemical kinetics. Give preference to electrochemistry and chemical kinetics. Electrochemistry is one of the easy chapter. We will get direct question based on Nernst equation, direct question based on Faraday's law, or direct question based on molar conductance, equivalent conductance, resistance, conductivity, all those calculation part. So here you guys can able to write 2 question. Yes. Apart from that, chemical kinetics, order, half-life, Arrhenius equation. Very simple, direct question. Directly you guys can able to attempt 2 question. Now, basic concepts of chemistry. Short, we will be getting one question based on mole concept. One question will be there based on mole concept. Now, when it comes to solution, short, if you don't know RLVP, whatever, no, one question will be based on Van 't Hoff factor. So now I will tell, because majority of the students are feeling very tough when it comes to physical chemistry part. Honestly, I'm telling, listen carefully. To get this 2 question in atomic structure, focus on Bohr derivation part. Apart from that, hydrogen spectrum, quantum numbers, node. More than sufficient, my dear students. More than sufficient. In basic concept of chemistry, I will come later. In solution, to attend that one question, focus on Van 't Hoff factor. If possible, along with Van 't Hoff factor, you guys can... Okay, why mood of Subhashri? What happened? So when it comes to solution, we can expect question from Van 't Hoff factor. Along with that, read osmotic pressure also. Osmotic pressure. Then now I will tell to attempt chemical kinetics 2 question. Integrated rate expression. Apart from that, half-life. The major thing is Arrhenius equation. Short, you guys can expect question from this. Arrhenius equation. Now, when it comes to electrochemistry, as I told, you guys need to focus on Nernst equation, followed by Kohlrausch law, that is infinite dilution. Apart from that, you guys need to focus on remaining the law of electrolysis. I'm not writing here, but remember resistance, conductance, all those formulas. Okay. When it comes to thermodynamics, read only the basic terms. Read only the basic terms. When it comes to equilibrium, stick to Kp-Kc expression and then Le-Chatelier principle. Le-Chatelier principle. In basic concepts of chemistry, based on mole calculation, we will get. No, Ammo, I didn't do that. No. Today only in another batch, actually, I'm having that. I'm just going to do it. So in basic concepts of chemistry, do question based on basic mole concept question. Basics. Mole related numericals. Or else focus on limiting reagent. Like they may ask which of the following is having more molecules. Which of the following is having very less molecule. So if you guys read these topics, when it comes to redox, we know very well balancing related question will be there or oxidation state. Very simple chapter. See whatever the number of question I given here is minimum question, minimum short question. Who knows, if the question paper setter may ask high level of question also. There is a possibility is there. Here whatever the question I mentioned is very short minimum question. Minimum number of question. What is the minimum number of question I can expect in redox? One question. But if the question paper is easy, honestly, chemistry paper will be easy, my dear students. So you guys can expect automatically 2 to 3 question also. Who knows? But let us imagine paper will be tough first paper. In that perspective, we will prepare. So if you prepare only these topics, how many questions you guys can able to attempt? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So out of 15 question, you guys can easily able to attempt 11 question. Now tell me, 44 marks in physical chemistry. From my lecture of organic chemistry, 45 marks. So here itself, we scored 90 marks. Now from inorganic chemistry, if we score, again automatically our score is 140 in chemistry. 140 in chemistry, 140 in physics, 360 out of 360 in biology. GMC is guaranteed. But the problem here is, till the last moment, we will be keep on focusing on, sir, in physical chemistry, thermodynamics will come, I will read. In physics also, thermodynamics. My question, in this last 7 days, why you guys are wasting your precious time by sitting in the unwanted topics? We know very well in solution, other than Van 't Hoff factor, osmotic pressure, RLVP numerical will be there, but they may complicate it. The question paper setter, if they want to frame a tough paper, they may bring JE advanced RLVP numerical into the question paper. You guys tell me how it is possible for us to solve. It will be really tough. So that is what, my dear students, everybody getting an idea. So yes, Ananya, everyone, very good morning. Sorry, sir, I'm late. Hey, it's fine. No problem. So these topics, only these topics is sufficient. Directly, I'm telling. This is the minimum question, guaranteed minimum question. If you people want, I will write and sign and give. This is the minimum question we can expect. 11 question. This is the minimum. Again, I'm telling you, even you people know very well, I know very well. Equilibrium, only one question. KP, KC, Lee Charlier principle. Who knows? If we get pH related question, we know all the formulas. In class, I discussed all the formulas. Vignesh, good morning, sir. Good morning, Vignesh. Yes, in class already we solved all the formulas. Now tell me one thing. Whatever the topics I written here, you people know these topics. Now, when it comes to physical chemistry, to solve question, no need of topics. Sir, I do this as I am at 0 in physical chemistry. Will I get 60 marks? No, you won't get 60 marks. You will get only 44 marks. 44 is the minimum. If question paper is tough, you will get 44 marks. If the question paper is easy, you will be getting 45 plus. Who knows? 50 also possible. Right? Now tell me these topics, each and every one of you know or not? Yes. Now, no need, honestly telling, I am talking about concept. To solve physical chemistry question, no need of concept only, my dear students. See, concept and all we require to score full marks in our CBSE board examination, to score full marks in our state board examination, whether you are from Karnataka, Tamil Nadu, Andhra Pradesh, whatever, intermediate, college, what PU, whatever it is. But one thing you guys need to be very, very clear. To solve these questions, if we have some basic idea, that is more than sufficient. So in today class, now what I am going to do means, in a very, very selected way, I am having some top questions from physical chemistry. I am just going to give those questions, try to solve. Okay, I'm just going to give those top level question, try to solve from these topics, mainly from these chapters. All physical chemistry chapters I written. For some students, thermodynamics, what I did, here I am telling only 44 marks, but in the same channel, one strategy video I did. For thermodynamics, I given one tabular column. With the help of that, you guys can able to solve complicated numericals also. For redox, I just given balancing trick. I just given the balancing trick, how to solve redox reaction in the first marathon of 10 hours. This is there in the strategy video in this particular channel. If you go and search in the video section, you guys can able to see this tabular column. With the help of that, not this one question, one more question will come. That question also you guys can able to solve. Redox balancing trick I told clearly. Apart from this, in equilibrium, what I given? All the pH formula in my first marathon 10 hours class. I given all the pH formula, how to remember, how to solve question based on buffer solution, salt hydrolysis, everything I given. Right? So, honestly telling, if you people followed me properly, you guys can able to score 60 out of 60. But in the last moment, at least give importance to these topics and then prepare well. Ananya, yeah. Really, sir, I didn't watch it. Yes, really. Thermodynamics will be there. One simple tabular column, with the help of that, you guys can able to score marks. Redox balancing trick, I in first marathon, 10 and a half hours marathon. This also in the first marathon, I clearly explained everything. Right? Now, is everyone is ready to solve questions based on this? Or you guys want me to once again revise the formula? Tell me honestly. Sir, take atomic structure, revise the formula, then we will solve question. Take equilibrium, revise the formula, then we will solve question. Like that, you people want me to continue this class, or directly shall we start solving question? Tell me, my dear students. Or directly shall we do question? Quick, please do tell me what we will do. Yes, need to revise, sir. Others, Farzana, revise formula, sir. Sicily, yes, sir. Yes, sir. For what? Revising formula. Yes. Okay. So in a very precise way, I'm going to revise the formula. Nothing like beating around the bush, nothing. Revise formula, sir. Revise formula, sir. Okay. Now, I will take one topic. I will revise the formula. Then we will continue with the things. Okay. Yes. Revise and solve together. Okay. Okay. That's good. Fine. So now I will take, these are all the topics is very important. I will take one particular chapter. I will give all the formulas in a very precise way. Then we will solve question. Honestly, I'm telling, whatever the formulas I'm going to give, no, please do make a note of it. That is more than sufficient. Even in my absence, you guys can able to solve question. Even in my absence, you guys can able to solve question. So please do make a note of all the list of formulas, whatever I'm going to write. Clear? Perfect. Now, let me start. First thing. First, I'm going to start with atomic structure. First thing is atomic structure. What we discussed in atomic structure? Bohr derivation, hydrogen spectrum, quantum number, node. From these, we can expect questions. But now, when it comes to formula discussion, I will be just giving all the things. I just going to give all the things. Please do make a note of it. First thing, when it comes to atomic structure, what is the major thing we need to remember? Mass of proton. Who knows? They may ask question from this also. Mass of proton is 1.67 into 10 to the power minus 27 kg. This is the mass of proton. In AMU, if I want to write, how I will write? Mass of proton is 1.0075 AMU. In the same way, if I talk about anode ray, remember one thing very, very important. When it comes to anode ray, what we can able to tell? E by M ratio. E by M ratio is, remember this, very important. E by M ratio is independent. E by M ratio is independent of nature of gas taken in discharge tube. Nature of gas taken in discharge tube. This is all about anode ray. Next, when it comes to neutron, what is the mass of neutron? Yes, mass of neutron. What we can able to tell? 1.67 into 10 to the power minus 27 kg. In the same way, what will be its mass? Mass of neutron in terms of AMU, that will be 1.0085 AMU. Let me represent neutron in small n only. Mass of neutron, mass of neutron. Apart from this, then electron. Mass of electron is 9.1 into 10 to the power minus 31 kg. Then if I want to write normally in AMU units, mass of electron will be 0.000549 AMU. It is clear. So these are all the values, very important. Maybe we can expect question from AR type, statement type question. Whenever those type of question comes, we can expect these models. Mass of electron, mass of neutron, and then mass of proton, anode ray. Now, when it comes to atomic model, remember one thing very, very important. When it comes to Rutherford model of an atom, what exactly we know? From Rutherford model of an atom, what exactly we know? This is very, very important. Rn, that is radius of nucleus, will be equal to R0 into A power 1 by 3. What is Rn? Rn represents radius of nucleus. Rn represents radius of nucleus. In the same way, A represents mass number. What is the value for R0? R0 value is 1.33 into 10 to the power minus 13 centimeter. Remember the units, my dear students. This is where majority of the students will do mistake. When it comes to nucleus, what will be the diameter? When it comes to nucleus, diameter, what is the diameter of the nucleus? 10 to the power minus 12 to 10 to the power minus 13 centimeter. In the same way, when it comes to atom, what will be the diameter of the atom? It will be 10 to the power minus 8 centimeter. So remember, I'm not telling the radius, I'm just telling the diameter. It is clear. So these are all the very basic thing we need to remember. Now the next thing, other than that, other than these concepts, from where we can expect remaining question? Mass of proton, mass of neutron, and then mass of electron. In the same way, Rutherford model of an atom, then followed by that nucleus of atom, diameters, then this is anode ray discharge tube. It is clear? Yes. Next from where we can expect question? Electromagnetic spectrum. Next, actually, we can expect question from electromagnetic spectrum. Electromagnetic spectrum. What is the formula for when it comes to electromagnetic spectrum? What are the things we can write? C is equal to mu lambda. First formula is C is equal to mu lambda. Otherwise, we can also write it as mu is equal to C by lambda. Yes, C is equal to mu lambda. So, mu is equal to C by lambda. Or else lambda is equal to what we can able to write? C by mu. Anything we can rearrange and write. Now, remember one thing. What is wave number? If suppose I am rearranging this for lambda. Lambda is equal to C by mu. Now, wave number, it is nothing but reciprocal of wavelength. So, wave number is nothing but mu by C. Mu by C is nothing but wave number. Next, time period and then frequency. What is the relation? When it comes to time period, it is reciprocal of frequency. Time period is reciprocal of frequency. Next, we know one famous formula, E. What is the E? Energy. E is equal to hc by lambda. What will be the h value? 6.626 into 10 to the power minus 34 joule second. H is equal to 6.626 into 10 to the power minus 34 joule second. If the energy I want in electron volt, if the energy value I need in electron volt, then automatically lambda we will be taking in Armstrong unit. So in the numerator is fixed 12,400 divided by wavelength in Armstrong unit. So with the help of this formula, I can able to calculate energy in electron volt. Then I can convert it into joules per second. It is clear? So these are all the very important formulas. Now, sometimes the question paper setter will ask total amount of energy transmitted. How we can able to write? E is equal to NH mu or else NHC by lambda. These are all the things we need to remember when it comes to electromagnetic spectrum. These are the formulas we need to remember when it comes to electromagnetic spectrum. It is clear, right? Apart from this, nothing is there in atomic structure. Now, immediately I will just go and solve questions for you guys. Followed by this, the next one, Bohr model of an atom. We know very well. When it comes to, as I told, this is very important, my dear students, in exam point of view. When it comes to Bohr's atomic model, what is the formula we can tell? First thing, what we know? MVR is equal to NH by 2 pi or MVR is equal to NH cross. H cross is nothing but H by 2 pi. What is the radius formula? 0.529 into N square upon Z Armstrong. What is the velocity formula? 2.188 into 10 to the power 6 Z by N meter per second. Then when it comes to energy, if I talk about energy, what energy I am talking? Total energy, that is minus 13.6 into Z square upon N square EV per atom. If I want to talk about total energy, potential energy, kinetic energy, remember one thing, my dear students, potential energy is equal to minus 2 times of kinetic energy. Then what is the relationship between kinetic energy and total energy? Kinetic energy is nothing but minus of total energy. So automatically potential energy, total energy is nothing but potential energy is equal to 2 times of total energy. 2 times of total energy. This is very, very important. Next, actually, what we will discuss? Revolutions. Based on this also, sometimes we'll ask question, revolution per second. Per second is given by mu upon 2 pi r. Revolution per second is given by mu upon 2 pi r. If suppose time taken for complete revolution, reciprocal of this, time taken for complete revolution, that will be 2 pi r upon mu. Time taken for complete revolution is 2 pi r upon mu. Now, energy difference between two energy levels. How we can able to tell? Energy difference between two energy level. Very simple. Remember one thing, this is very, very important. Energy difference between two energy level. When it comes to energy difference between two energy level, that is delta E. Higher energy level minus lower energy level. So automatically now what is the formula I can use? 13.6 into Z square. 13.6 into Z square upon 1 by N1 square minus 1 by N2 square. So we can use this formula to calculate difference in energy. What will be the units? We will be getting the units in EV by atom. We will get the units in EV by atom. If I want to use ionization energy, then change in difference, change in energy will be equal to ionization energy into 1 by N1 square minus 1 by N2 square. 1 by N1 square minus 1 by N2 square. Now, IE is nothing but it is called as ionization energy. How to find out ionization energy? Very simple. Remember one thing, ionization energy is the energy difference between from energy infinite level minus energy of ground state. Energy at infinite is 0. 0 minus energy of ground state. 0 minus energy of ground state. So, what is EGS? Energy of electron in ground state. Energy of electron in ground state. What is IE? IE is nothing but ionization energy. IE is nothing but ionization energy. So these are all the list of formulas. First, you guys need to remember when it comes to atomic structure. Mass of proton, neutron, electron, Rutherford model of an atom, radius of nucleus calculation, what is nucleus diameter, atom diameter, anode ray, and then when it comes to electromagnetic radiation, what are the different formulas, followed by that Bohr atomic model. So this is very, very important. Definitely you guys will get question. Apart from that, energy difference between two energy level. It is clear. So these are all the important formulas we need to remember. The next thing, short question. From where exactly we can expect the question? We can expect from hydrogen spectrum. The next thing, from where we can expect question is hydrogen spectrum. When it comes to hydrogen spectrum, what is the formula we know? Hydrogen spectrum wave number. That is nothing but reciprocal of wavelength, R into Z square upon 1 by N1 square minus 1 by N2 square. So we can use this formula to calculate wave number, hydrogen spectrum. What is R value here? R value is nothing but 109700 centimeter inverse. This R is exactly called as Rydberg constant. This R is exactly called as what? R is called as Rydberg constant. Now, one more thing. Remember one thing, first line of a series. That means how to find out for a first line of series, N2 value will be equal to N1 plus 1. Limiting spectral line, that means series limit. Very simple. Let me write all those things, then you guys will understand. Limiting spectral line. In question paper, the question paper setter will use the word limiting spectral line, or else series limit they will mention. Calculate the series limit. That means N2 value is nothing but infinity. In the same way, first line of series. First line of series. How to calculate? That is N2 will be equal to N1 plus 1. If I add plus 1 to the ground state, then actually it is called as first line of the series. What is then H alpha line? H alpha line will be, this will be the H alpha line. So this is nothing but, we will be calling it as H alpha line, first line. H beta line means second line. H gamma line means third line. H delta line means fourth line. So this is exactly first line. Now remember one thing. Longest wavelength means shortest frequency, least energy. So when it comes to hydrogen spectrum, remember longest wavelength means, so frequency will be shortest frequency, least energy. Yes, so this is very, very important. Done. Now the next thing, number of spectral line. That is very important, right? Now the next thing, number of spectral line. Please do make a note of it. Then we will calculate number of spectral line. Fine. Okay. Now, when it comes to number of spectral line, the calculation is very, very important when it comes to number of spectral line. How to do this calculation? Very simple. If the electrons jumps from, if electron jumps from higher energy level, electrons jumps from higher energy level to ground state, then what is the formula we can use? N into n minus 1 upon 2. If suppose electrons jump from higher energy level to other than ground state, some other lower energy level, to lower energy level, then what is the formula we will be using? Remember, n2 minus n1 into n2 minus n1 plus 1 divided by 2. Now remember one thing, this n represents what? Higher energy level. Here higher energy level is represented by n2, lower energy level is represented by n1. So these formulas are very, very important in exam point of view when it comes to calculations of number of spectral line. So these two formulas are very, very important. We can expect question from this. It is clear? Done? Anybody is having any doubts here? Next, when it comes to de Broglie hypothesis, that is very, very important. From de Broglie, what is the formula we know? Lambda is equal to h by mv, or we can call it as h by p. If suppose circumference of nth orbit, this is very, very important, my dear students, 2 pi rn is equal to n lambda. This is very, very important. When I can use this formula? circumference of nth orbit. Circumference of nth orbit is equal to what? N times of wavelength of electron. Nth orbit is equal to n times of wavelength of electron. This is very, very important expression. Remember one thing, number of waves. How to calculate number of waves means, number of waves is nothing but n. What is this n? It is nothing but principal quantum number. Number of waves is equal to n. N is nothing but principal quantum number. In the same way, wavelength of electron, one more formula is there. If you are dealing with volt, what is the formula? Lambda is equal to root of 150 upon V. Root of 150 upon V. What will be the units we will be having? Here the units will be Armstrong units. Here the units will be Armstrong units. Apart from this, one more formula. Lambda is equal to H by 2m kinetic energy. This is also one of the important formula we can use when it comes to de Broglie hypothesis. It is clear? So this is all about de Broglie hypothesis. Next, I will write the famous formula. You guys know very well what is that formula is all about. Heisenberg uncertainty principle. Heisenberg uncertainty principle. So what is the formula for Heisenberg uncertainty principle? Delta x into delta p greater than or equal to h by 4 pi, or else the same thing I can write delta x into delta v greater than equal to h by 4 pi m. Direct question you people will get, my dear students. We will get direct question, right? We will get direct question, right? Other than this, the main thing is quantum number. We know very well. In quantum number, where students are having confusion, those things only I will give. Quantum number. Because even I am not expecting, but these are all the places students are getting confusion when it comes to quantum number. That now whatever I'm going to tell, please do make a note. Total number of electron in an orbit. Total number of electron in an orbit. In an orbit. Next one, total number of orbitals in an orbit. Total number of electrons in an orbit, total number of orbitals in an orbit, total number of subshell in an orbit. Definitely question paper setter will focus on these questions. Total number of subshell in an orbit. What is the formula? Anybody can tell me? Yes? Anybody can tell me? What is the formula when it comes to these three? Yes. What will be the formula? Total number of electrons in an orbit, total number of orbitals in an orbit, total number of subshell in an orbit. Very, very important. What is the formula? Total number of electrons means 2n square. Total number of orbitals means n square. Total number of subshell means n. So please do remember this formula. What is n represents? N represents principal quantum number. If suppose angular momentum they are asking. angular momentum. Then what is the value? NH by 2 pi. If angular momentum they are asking, then what is the formula? NH by 2 pi. If suppose instead of principal quantum number, azimuthal quantum number is given. Now tell me the formula to calculate total number of electrons in a suborbit total number of electrons in a suborbit. Understand the difference. In the same way, total number of orbitals in a suborbit. Total number of orbitals in a suborbit. Tell me, what will be the formula? Yes. Here, what will be the formula? Quick. Yes, yes, yes. Tell me, my dear students, what will be the formula here? In the meantime, let me drink water. Yes. So, very simple thing. Total number of electrons in a suborbit means 2 into 2l plus 1. Total number of orbital in a suborbit means 2l plus 1. Here 2 into 2l plus 1, total number of orbitals in a suborbit means 2l plus 1. It is clear? So these are all the things very, very important. If suppose angular momentum is equal to nh by 2 pi. Now instead of this principal quantum number, if azimuthal quantum number is given, that is L is given, how to find out orbital angular momentum? If instead of principal quantum number, azimuthal quantum number is given, how to find out orbital angular momentum? What we know? Orbital angular momentum, root of L into L plus 1 H cross. So remember, my dear students, this is just an angular momentum. This represents orbital angular momentum. This formula represents orbital angular momentum. What is H cross? H cross is nothing but H upon 2 pi. It is clear? So these are all the things you guys need to remember. No one is going to ask you guys explain quantum number, all those things. Directly remember these things, just get the values. That's all. It is clear? Done? That's all, my dear students. This is all about atomic structure. Now, if you people remember these things, no, it will be very easy for us. Remember one thing, node antinode calculation. What is the formula to calculate node? Yes, node calculation. Anywhere space is there? Yeah, here space is there. Let me write node formulas also. Let this be like a formula book. What is total node? N minus 1. What is radial node? N minus L minus 1. What is angular node? Angular node will be equal to L, azimuthal quantum number. What is nodal plane? Nodal plane will be equal to azimuthal quantum number. These three things are very, very important. Four things. These things are very, very important. So total node is nothing but N minus 1. Total node is nothing but N minus 1. Radial node is nothing but N minus L minus 1. Nodal plane is L. Angular node is L. It is clear, right? So let me give just 30 seconds of time. Take a screenshot also. When it comes to first chapter, atomic structure, you guys need to remember only these things. That is more than sufficient. That's all. To score marks, direct numericals will come. So remember now onwards, when it comes to atomic structure, mass of proton, mass of electron, mass of neutron, how to calculate radius of nucleus with the help of Rutherford model of an atom. In anode ray, only one thing, E by M ratio is independent. Electromagnetic radiation, how energy, wavelength, velocity, everything is related. Apart from that, Bohr's atomic model, radius, velocity, energy, potential energy, kinetic energy, total energy relation, node calculation, energy difference between two energy levels, how to calculate. Apart from that, hydrogen spectrum, this is very, very important. Followed by that, number of spectral line. If electrons from higher energy level to ground state, then we need to use this formula. If electron comes from higher energy level to lower energy level, then we need to use this formula. Remember one thing, N2 represents higher energy level, N1 represents lower energy level. In the same way, from higher energy level to ground state, that is higher energy level is N, that is N into N minus 1 by 2. De Broglie wavelength is very simple, lambda is equal to H by mv. So these are all the different relation. Don't forget this formula. This is very, very important. This is very, very important. 2 pi r is equal to n lambda. Apart from that, Heisenberg uncertainty principle. So this is the formula we need to use, followed by quantum numbers. It is clear. Atomic structure is done and dusted. Clear? So please do take a screenshot quick. Only 3 pages. First one, second one. I'm not hiding the board, I believe. Yes. So this is the first one. This is the second formula. This will be the third one. Now, shall we move into the next chapter? That's all. First, we will revise all the chapter as fast as possible. How can I develop English like you, sir? Start talking, my dear student. Start to speak. Actually, automatically you can able to do it. Done, understood. Crystal clear, sir. Okay, fine. Perfect. Now, because the duration is very limited for us today, I'm not going to take 6-hour class. The class is of only 2 to 2.5 hours duration. So already since 1 hour completed, today we will try to give all the formulas. We will discuss all the chapters like this. After that, what we can able to do with the help of this, you guys itself can able to solve numerical, or else in another class I will come with numerical. Okay, so today make a note of all these formulas, whatever I'm going to discuss, that is more than sufficient. Perfect. Now shall we move into the next topic? Next to atomic structure, what is very important? Basic concepts of chemistry that everyone know, I believe. Right? So basic concepts of chemistry is a problem, my dear students. Tell me. Yes, I'm not going to give equilibrium, thermodynamics, because tabular column is already given in the strategy video. Equilibrium I completely discussed in first class of 10 hours marathon. The 10 hours marathon you guys can able to see in live section of that same channel. Tabular column, this video you guys can able to see in the video section of this particular channel. Balancing trick also I did in 10.5-hour lecture. Now directly after discussing atomic structure, now I'm going to discuss chemical kinetics, electrochemistry solution, because 12th class portion is very important. Why? From 12th class we will get 55% of the syllabus, 11th class is of only 45%. So here also in this 15 question, if I split accordingly, 7 to 8 question we will get here. 7 to, I will watch the video after class, sir. Okay, Ananya, yes. So 7 to 8 question will come from class 12. So the next I am going to continue with chemical kinetics. Very, very important chapter, my dear students, chemical kinetics. So shall we start? Yes. Chemical kinetics, electrochemistry is very, very important. Yes, direct formulas we need to remember. That's all when it comes to chemical kinetics. Okay, sir, let's start 12th. Yeah. So the next chapter, what we are going to discuss is chemical kinetics. Chemical kinetics. Directly, as I told, what is very important? Half-life, integrated rate expression. So remember only those things when it comes to chemical kinetics. Remember, the first thing, if I am having one general expression, Na plus Mb gives Pc plus Qd. How it is possible for us to write the rate of disappearance and appearance? Very simple. First, let me write. In a short form, I will write because each and every student, okay, that's fine. Rate of disappearance. How I can able to write? Minus dA by dt. In the same way, I can able to write minus dB by dt. Rate of appearance, rate of disappearance talks about reactant. Rate of appearance talks about product, because we know very well once the reaction starts to happen, what will happen? Concentration of the reactant decreases, concentration of product increases. So rate of appearance, when it comes to rate of appearance, plus minus sign represent it is decreasing, positive sign represent concentration is increasing. So plus dc upon dt is equal to plus dd upon dt. Now, one more thing, remember carefully. This is rate of appearance, this is rate of disappearance. Now, for the same reaction, for the same balanced chemical equation, if I want to write average rate of reaction, otherwise rate of reaction, how we can able to write? Rate of reaction, if I want to write the rate, how I can able to write the rate expression? Minus dA by dt is equal to minus dB by dt is equal to plus dC by dt. Then finally what we will be having is equal to plus dd by dt. Am I right? Now, if you listen carefully, my dear students, now what will be the next thing we will be exactly having? Now, understand, when it comes to rate of appearance, we are not even bothering about stoichiometric coefficient. Am I right or not? We are not even bothering about stoichiometric coefficient. But remember one thing, when we are about to write average rate, what we need to do? When it comes to average rate, we need to consider the stoichiometric coefficient. So automatically here, what is the stoichiometric coefficient? NMPQ. So we need to write stoichiometric coefficient will come in the denominator, NMPQ. It is clear. So remember one thing, my dear students, when it comes to rate, whenever the question paper setter is asking us to write the rate, we need to remember one thing, stoichiometric coefficient will come in the denominator. It is fine. So the very basic thing, first you guys need to remember this. Clear? Please do make a note. So in general, how I can able to write? Rate. Rate is nothing but rate of appearance or disappearance upon stoichiometric coefficient. So how I can write? In general representation, I can represent it as rate is equal to rate of appearance upon rate of disappearance divided by stoichiometric coefficient. Now appearance disappearance means we will be having plus and minus sign. So mention here plus or minus. Rate will be equal to plus or minus rate of appearance or disappearance upon stoichiometric coefficient. It is clear. Anybody is having any doubts now? Clear? Anybody is having any doubts? No doubts, right? Yes, perfect. Now, apart from this, in this particular chapter, in the last moment, what are the things we need to know? As I told always, half-life, integrated rate constant expression, both are very, very important. Now, before that, what will be the order general? Let me write rate law. In a single page, I will try to complete this chapter because it will be very helpful for us for the last minute revision also before the day of exam, early morning. Rate law. What we know? Rate is directly proportional to concentration of reactant raised to the power x. This x is exactly called as order. X is nothing but it is called as order. To remove the proportionality sign, I will introduce one constant. So rate is equal to K into reactant to the power X. Now, if I talk about order, order is basically a experimental quantity. Order is basically a experimental quantity. Now, remember one more thing. Sir, you teach very fast. What your concern? Am I teaching very fast or you want me to increase my speed further? Preetham. Now, order is the experimental quantity. Remember one thing, this order will be equal to stoichiometric coefficient. This order will be equal to stoichiometric coefficient. When this order can be equal to stoichiometric coefficient? For elementary reaction. For elementary reaction. That is elementary. What is the other name we can tell? Single step reaction. We know very well. Some reaction in chemistry will takes place in single step. Those reactions are called as elementary reaction. For those particular reaction, order will be equal to stoichiometric coefficient. Order will be equal to stoichiometric coefficient. Now, one more thing. This K, this is called as rate constant. How to calculate the unit of rate constant? Remember one direct formula. Unit of rate constant is given by the formula mole liter time inverse. Mole to the power, what to mention? Now that will be the question, right? So remember this thing directly. Mole to the power 1 minus n. Mole to the power 1 minus n. Liter to the power. For example, if it is zero order reaction. Okay, Shiva Prakash. Good morning, sir. Because of test, I couldn't able to attend the live session. I am watching the recorded video. Thank you for teaching salt analysis. Okay, Shiva Prakash. Yes, I think that is more than sufficient. Actually, I need to discuss confirmatory test for basic radical is pending. So that also I will give like a flow chart before exam. Don't worry. Tomorrow or day after tomorrow, I will post that as a strategy video. Confirmatory test for basic radical. Yes. This speed is perfect, sir. Okay. Exam is approaching, Noma. That's why I'm going a little bit faster. Okay. Because now we are not starting our preparation to teach very slowly. Now it is like a revision. Unit of rate constant, remember the direct formula, mole to the power 1 minus n. Now liter to the power, what exactly we will be getting? Yes, mole per liter. Otherwise, I will write like this in a general way. Concentration, mole liter minus 1 to the power n minus 1. Like this also we can write. Super translation, sir. Robin is very busy in chatting with his friends. So n, what does this n represents? N represents order. So first order reaction means substitute 1 in place of n. Second order reaction means substitute 2 in place of n. Third order reaction means substitute 3 in place of n. That's all. So what we need to do is we just need to remember this general formula. This is exactly unit of rate constant. Now for zero order reaction, what is the expression? Yes. For zero order reaction, what will be the expression we will be having? Integrated rate expression. Zero order reaction, first order reaction. Remember, when it comes to zero order reaction, T of is equal to A naught upon 2K. For first order reaction, T of is equal to 0.693 by K. T of is equal to A naught upon, sorry sir, no need of sorry, Robin. T of is equal to A naught upon 2K, T of is equal to 0.693 upon K. I can understand your mindset, Robin. See, he told sorry and then he deleted his comment. Okay, fine. So T half is equal to A naught upon 2K, T half is equal to 0.693 upon K. K represents rate constant. Now, when it comes to integrated rate expression, how we know? Remember directly, last minute, no need of ln, all those things, because we can able to solve questions when it comes to logarithm only. Better keep the logarithm formula directly. K is equal to 2.303 upon T log of A minus X, final concentration upon initial concentration. Log of A minus X upon, yes, once again, A by A minus X, very sorry. Log of A by A minus X. A represents initial concentration, A minus X is concentration after particular time T. Next thing, when it comes to zero order reaction, immediately we can able to do, if I am writing rate, minus dA by A is equal to K we will be having, right? Because zero order reaction. For example, let me write like this. Imagine one reaction. R is equal to K into A power 0. Anything per 0 is 1. Now, minus dA by dt is equal to K. Automatically, what we will be having? Minus dA is equal to K dt. Upper limit minus lower limit. So, what exactly I will be having? Here, I will be having KT is equal to, here, upper limit minus lower limit. What will be the upper limit? Final concentration minus lower limit. So what will be the expression? KT is equal to A naught minus AT. Instead of doing this derivation, directly remember AT is equal to, KT is equal to A naught minus AT. K is equal to A naught minus AT upon T. Like this also we can remember. Just remember the direct formula. Pradeep, hi Pradeep. Why 1 dot, 2 dot, now hi? So K is equal to A naught minus AT upon T. It is clear. So these are all the expressions we need to remember. Very, very important. If suppose, sir, half-life, any general expression is there. What question paper setter can ask is, when it comes to zero order reaction, T half depends on initial concentration. When it comes to first order reaction, T half independent of initial concentration. That is very, very important. When it comes to rate, if I want to write rate, how I will be writing? Rate is equal to K into concentration of reactant raised to the power 0. Zero order reaction. For first order reaction, rate is equal to K into concentration of reactant raised to the power 1. Now understand these things, whatever I am going to tell now orally, that is very, very important in exam point of view. When it comes to zero order reaction, half-life depends on initial concentration. When it comes to first order reaction, half-life independent of initial concentration. When it comes to zero order reaction, rate is independent of initial concentration. When it comes to first order reaction, rate depends on initial concentration. These four statements are very, very important in exam point of view. It is clear. Once again, I am repeating, when it comes to zero order reaction, half-life depends on initial concentration, rate independent of initial concentration. If I talk about first order reaction, half-life independent of initial concentration, but rate depends on initial concentration. That's all. So these are all the things very, very important. Now, what type of question the question paper setter can frame means, he or she may ask half-life and then initial concentration, how they are related. So every time it is not possible for us to remember the things, right? So for that purpose, one general formula I will give. T half is inversely proportional to A naught to the power. Now, when it comes to zero order reaction, it is directly proportional. So, what is the formula I will be writing? N minus 1. You guys can use this general formula. What is N? If it is zero order reaction, substitute 0. First order reaction, you guys can substitute 1 there. It is clear, right? So, we can, N represents order. Any criteria is there, sir? it is possible for me to use this particular expression up to certain number. Yes, we are having the things for n greater than or equal to 2. We can use this for n greater than or equal to 2. It is clear? Done. So these are all the things you guys need to remember when it comes to chemical kinetics. The last equation you guys know very well. What is that? Arrhenius equation. Yes. The last thing is Arrhenius equation. Arsan, sir, I could not understand this topic. Why, ma? Which class actually you are doing now? Are you a dropper or you are in which class? I am late today. No problem. From the beginning, you see, automatically you can able to understand. Yes. So directly remember Arrhenius equation formula. What is the formula for Arrhenius equation? Let me write in the new page. Arrhenius equation. K is equal to A into E power minus EA by RT. So the expression is actually Arrhenius equation. Now one more thing. Now 12th class, sir. Okay. Now only 12th class means actually 11th to 12th going student, right? So time is there, don't worry. In school, college also they will teach no chemical kinetics. Wait, it is in 12th class. So K is equal to A into E power minus EA by RT. Otherwise, what is the expression we can write? Log K2 by K1 is equal to EA upon 2.303 R. EA upon 2.303 R. T2 minus T1 upon T1 into T2. We can able to write like this, or else 1 by T1 minus 1 by T2. Otherwise, remember like this, 1 by T1 minus 1 by T2. It is clear. So with the help of this expression, we can able to do it. Now, one more thing I just want to tell. In radioactive decay, maximum question paper setter won't focus on this, but still, in a radioactive decay, what we know? Nt is equal to n naught e power minus lambda t. This is very, very important. Now, amount of, just have an idea, for that purpose I'm writing. Amount of radioactive substance after, the amount of radioactive substance after n half-life periods. How to calculate? Very simple. Nt is equal to 1 by 2 to the power n naught. So this is very, very important expression. It is clear. Then the last thing is temperature coefficient. How to calculate temperature coefficient? Temperature coefficient. K T plus 10 upon KT value will be equal to 2 to 3. If temperature coefficient is not given, generally we will assume it as 2 only. Okay, then we will be assuming it as 2 only. So these are all the things about chemical kinetics. It is clear? Yes, it is clear. So this is all about chemical kinetics. Why I'm doing this means, see, if you are in any of my other batch, I am the one teaching from the beginning of the year. So all my students already know all these things, right? All my students already know all these things because they are having each and everything. because my class notes, that is more than sufficient. But here in this channel, since I'm taking very recently, now when it comes to physical chemistry, at least in today class, due to time constraint, I want to give all the formula sheet, so that next class what I will do, directly I will solve questions. I can tell to the students also, just go and refer this particular video. That's all. That is the reason. Even these formula sheets will be really helpful for you guys. Clear? Chemical kinetics. So atomic structure is done. Chemical kinetics, remember rate of disappearance, appearance rate, and then rate law, unit of rate constant, zero order reaction. First order reaction is very important. Based on this direct question we will get, my dear students. Direct question, just a direct question. Then Arrhenius equation. Now shall we move into solution chapter? Shall we move into solution chapter? Is everyone is ready? Yes. Yes. Now the next one is solution chapter. Next thing, solution chapter. Solutions. When it comes to solution chapter, what are the things we can tell? First, concentration term. Definitely we will get the question, but anyhow, majority of the students know about this concentration term in our 11th class only. Right or not? But still, some of the important concentration term I will give, make a note. Concentration terms. First, what we need to know? Molarity. Number of moles of solute, weight of solvent in kg, or else number of moles of solute, weight of solvent in gram into 1000. Molarity. Molarity is equal to 10 into weight by weight percentage into density of the solution divided by molar mass of solute. Or else molarity is equal to 10 into weight by volume percentage divided by molarity of the solute. These are all molarity formula. Now when it comes to molality, molality is number of moles of solute divided by molarity, no? Molarity, what will come in the denominator? Number of moles of solute divided by volume of solution in liter, volume of solution in ml. Fine. Now molality. Molality is number of moles of solute, weight of solvent in kg. Number of moles of solute, weight of solvent in gram into 1000. The next step, molality. Molality and molarity relation. 1000 into molarity divided by 1000 into density of the solution minus molarity into molar mass of solvent. This is very, very important. So apart from that, molality is equal to 1000 into mole fraction of solute into 1 minus mole fraction of solute into molar mass of solvent. Here solute, my dear students. Yes. Here molar mass of solute. Here molar mass of solvent. Now what is the relationship between molality and molarity? That is what this relation. Oh my God, what happened? What happened, Bhavna? Yes. So these are all the very important concentration term. So this is all about molarity. This is all about molality. Then when it comes to normality, what is normality? Number of gram equivalents, number of gram equivalents upon volume of solution in liter. Now what is number of gram equivalents? Number of gram equivalents is nothing but, yes, anybody? Given weight upon equivalent weight. What is equivalent weight? Equivalent weight is nothing but molecular weight upon n factor. What is n factor? N factor is also called as valency factor, or we will be calling it as number of electron transfer. We will be calling it as number of electron transfer. So in redox reaction, we would have done this. Now in the place of equivalent weight, can I substitute this? So automatically number of gram equivalents will be equal to given weight upon molecular weight divided by n factor. So that will goes to the numerator into n factor. Now given weight upon molecular weight, it is nothing but number of moles. So number of gram equivalents is also called as number of moles into n factor. Now what is the relationship between molarity and normality? It is very simple. Molarity will be into n factor is nothing but it is called as normality. So this relation is very, very important. We may get some basic question. Okay. Arsen, you can do one thing. Now you are in 12th class. So simultaneously you want to prepare for competition exams also means you can enroll in our Laksh NEET 2027 batch, right? So 2 days back class has been started and then it is going on. Even now I am talking, right? In this video, if you look into the description of this video, no, you can able to see that batch, Laksh NEET 2027 batch. You can enroll there. So automatically there you can prepare for your 12th boards as well as parallelly for NEET examination also. No, sir. If I want to enroll, I want to prepare for JE means a Laksh JE 2027 batches there. You can parallelly prepare for your board exam as well as JE examination. So both in both the batches, NEET as well as JE, questions will be, the concepts will be completely taught, followed by questions of higher level. Even I'm only teaching for NEET chemistry. So I will start from the scratch. Slowly I will build up the concept. I will stop in the advanced level. That's what is happening. You can enroll in those batch, Arsh. Okay. See, that is what, yeah, Bhavana, a NEET student, okay, hanged himself at last night. So one thing, my dear students, please see, exams will come and go. Exams is not the end for life. It is just we need to try. Yeah, those batch will not come in the YouTube, Arsh. Those batch you can able to access only by enrolling in the particular batch through our application. Okay, so please make use of it. Hey, sure, Ananya, don't worry. All my students will really do well in the May 3rd examination. Question paper will be of easy. Don't worry. See, chemistry, there is no option to take tough question. Chemistry will be always easy. Please don't worry. You guys will really do well. Okay? Yes. All right. So what is the relationship between molarity and normality? Normality is nothing but molarity into n factor. Molarity into n factor is nothing but normality. Next. Apart from this, anything is required in solution chapter? Yes. The question paper setter may focus on formality also. The question paper setter may focus on formality. Formality is very, very important. Then what is formality? It is not that formality, sir. For formality purpose, I am listening to your class. No, it is not that formality. Now, when it comes to one formal solution, we will be using formality is what means number of gram formula mass. Number of gram formula mass of solute upon volume of solution in liter. Number of gram formula mass of solute divided by volume of solution in liter. It is clear. Now, apart from this, what are the very important thing you guys need to know when it comes to this particular chapter is Henry's law. Now I am getting into solution chapter. Listen carefully. Henry's law. Henry's law is nothing but partial pressure of the gas is equal to kH into mole fraction of the gas. Partial pressure of the gas is equal to now Robin, no, Robin. Okay, fine. So partial pressure of gas is equal to Henry's constant into mole fraction of the gas. So this is very, very important. Now, one more thing, Raoult's law. Raoult's law. Remember, when it comes to solubility, remember, if KH value is more, solubility of gas will be less. The relationship between KH and solubility of the gas. When it comes to Raoult's law, what we know? Partial pressure of a particular component is equal to P naught A chi A, PB is equal to P naught B chi B. So total pressure PT is equal to P naught A chi A plus P naught B chi B. Otherwise, I can write it as PT is equal to PA plus PB. Now, when it comes to Dalton's law, relate this expression. PA is equal to P naught A chi A. Here also, PA is equal to PT into YA. PB is equal to PT into YB. So automatically, what we can able to write, if I want to write total pressure, otherwise pressure of the solution, let me keep like this. Instead of writing PT, I can write it as PS. So here also I can write it as PS. After adding solution, PS. So here also what PS will be equal to PTYA plus PTYB. So now, if you listen carefully, this expression and then this expression, we can able to equate, right? So we can able to equate. Automatically, we will be getting all the different formula. For example, based on this, they make ask question. If I equate these two formulas, what Dalton's law and Raoult's law, what I will be getting? P naught A chi A is equal to PTYA. P naught B chi B is equal to PTYB. So the question paper setter may ask us to calculate anything. So if the question paper setter is asking me to calculate anything, I can rearrange this expression. These two expression gives the relation between Dalton's law and then Raoult's law. Dalton's law talks about in vapor phase. Raoult's law is for in solution phase. It is for vapor pressure. That is in solution. This is for vapor phase. Okay, fine. Clear? Raoult's law, Henry's law. Now, remember one thing. Raoult's law is for what exactly? Raoult's law is for liquid in liquid solution. Henry's law is for gas in liquid. If I talk about colligative property, that is solid in liquid. Please do remember this also. The question paper setter may focus. It is clear? Then, now the next thing is colligative property. As I told just now, if I'm trying to dissolve solid in liquid, then it is colligative property. Then it is exactly called as colligative property. What are the formulas we will be having in colligative property? The first thing is relative lowering of vapor pressure, RLVP. I can write the formula as relative lowering of vapor pressure, P naught A minus PS upon P naught A is equal to IB. Or else I can write it as, instead of writing chi B, now this is revision, I into chi B. In the same way, elevation of boiling point. So what is the expression? Delta TB is equal to KB into I into M. M represents molality. I represents Van 't Hoff factor. In the same way, depression in freezing point. Elevation of boiling point, depression in freezing point. Delta TF is equal to KF into I into M. The next thing we can talk about osmotic pressure. Direct question you people will get, my dear students, in NEET examination. We are not preparing for JE. So osmotic pressure is nothing but Pi is equal to I into C into R into T. R is nothing but gas constant. Remember one thing, now how to calculate Kf and then Kb value. That is also very, very important. If I want to find out Kb, how to find out? R Tb square upon 1000 into boiling. That means we need to consider enthalpy of vaporization. We need to calculate enthalpy of vaporization. Otherwise, latent heat of vaporization. Latent heat of vaporization. Kf, depression in freezing point. So automatically what I will be considering here? Fusion. That is R Tf square upon 1000 into latent heat of fusion. It is clear. We can use all these formulas. What is Kb, Kc? Now the next question will come. Kb is called as molar elevation constant, or we will be calling it as molar depression constant. What is Kf? We can able to call Kf as one second, molar elevation constant or ebullioscopic constant. Ebullioscopic constant. Here Kf, depression in freezing point. So molar depression constant, or we will be calling it as cryoscopic constant. We will be calling it as cryoscopic constant. So these are all the formulas, very, very important. Now, when it comes to osmotic pressure, remember, if two solutions are having same osmotic pressure, then it is called as isotonic solution. If one solution is having higher osmotic pressure than another one, the higher one is called as hypertonic, the lower one is called as hypotonic solution. The higher one is called as hypertonic, the lower one is called as hypotonic solution. It is clear. Anybody is having any doubts? Now, what is this I represents? Very simple. That is Van 't Hoff factor. I, in all the formulas, I included I. You guys can able to see. So I represents Van 't Hoff factor. We need to include this. In case of solute particles getting associated, I is equal to n plus associated. Then I need to use the formula I is equal to 1 plus 1 by n minus 1 alpha. If the solute particle is getting dissociated, then I is equal to 1 plus n minus 1 alpha. What alpha represents? A degree of dissociation. N is number of moles of products obtained per mole of reactant. Number of moles of products obtained per mole of reactant. So whenever we are calculating number of moles of product obtained, suppose if the question paper setter is giving 2A gives 3B plus 1C. So we should not write n value is 4. That is wrong. 4 I am getting for 2 moles. So for 1 mole, how much I will be getting? 2. So n value should be 2. Like this, we need to calculate. It is clear? So these are all the things, very, very important. What are the other formulas to calculate I? Any idea? So other formulas to calculate I, that is nothing but observed colligative property divided by normal colligative property. Observed colligative property upon normal colligative property. Observed upon normal. Some more formulas we can use. What are the thing? theoretical or formula molar mass of solute divided by actual observed abnormal molar mass of solute. Theoretical or formula. So theoretical or formula molar mass of solute upon actual observed abnormal molar mass of solute. So these are all the formulas we need to remember. It is clear? Yes. So this is all about solution chapter. Anybody is having any doubts in the solution chapter? Quick, in solution chapter. So only these formulas we need to remember. Concentration term, and then Henry's law, Rawls law, Dalton's law, colligative property, all the formulas, van 't Hoff factor, when association what will happen, dissociation what will happen, how to calculate here. If we know all these things, solution is fine. It is clear? Complete formula sheet I am giving, my dear students. That's all. Yes, clear. Then anybody is having any doubts? So if you listen carefully, once again, I just want to, when it comes to physical chemistry, organic already done and dusted in last two marathon. When it comes to physical chemistry, before getting into question, in this last week time, 7 to 8 days, only we are having 8 chapters in physical chemistry. So definitely we will be getting minimum 1 to 2 questions from each chapter. So focus only on the subtopics, whatever I told. If you people solve questions from these subtopics only, we can easily able to score 11 questions. We can easily able to write 11 questions correctly. So 44 to 45 marks. So for this, what is required? Formula sheet. Atomic structure, I given the formula sheet in today class. You guys can able to see atomic structure, complete formula sheet I given. This is more than sufficient. You people will get direct question. Next, basic concept of chemistry. In 11th class, we already know very well. So there is no need of formula sheet. Otherwise, I will give you time permits. Equilibrium in 10 hours marathon. In the same channel, if you go to live section, you guys can able to see 2 marathon of chemistry. Part 1, part 2. In that part 1 marathon, 10.5 hours, I completely given all the formulas. I discussed everything with respect to equilibrium. Thermodynamics, in the same channel, go to strategy video. You guys can able to see the tabular column, or else once again, the same part 1 of 10 hours marathon. If you go, if you people see that, you people can able to see the tabular column or else strategy video in the same video. Apart from this, after that, redox trick also I completely given in the 10 hours marathon session. Okay, part 1 of 10 hours marathon you guys can see. Now when it comes to chemical kinetics, in today class I completely given all the formulas. In today class I completely given all the formulas when it comes to chemical kinetics. You guys can see here formula sheet for chemical kinetics. It is given, right? Now apart from that, which chapter we are having? Solution. So solution also complete formula sheet I given. It is clear? So that one chapter spending electrochemistry. If I give formula sheet for that chapter also, it will be fine. Yes. Now I am just showing the solution page to take screenshot. First take a screenshot of this page. Then we can start discussing electrochemistry. So after that, complete formula sheet you people are having. So we can start doing questions. Clear? Perfect. I hope I am not hiding the board. Next, this page. It is clear? Okay, sir, took it. Thank you. So the last chapter. So with this single thing, actually, this will be very easy for you guys, my dear students, to do this. Yes, the last chapter. So for the remaining chapters, please don't forget. Yes. So now let me start with electrochemistry. The last chapter. Electrochemistry. Understand one thing. When it comes to electrochemistry, one of the very easiest chapter, but majority of the students will always feel difficult. I don't know. Once again, direct questions will come. So please do make a note of whatever the formulas I am going to give. Okay. Product of electrolysis. Everything is important when it comes to electrochemistry. Shall we start? Yes. Okay. First, let me start. What is the first thing we know here is electrolytic cell. First thing is electrolytic cell. What electrolytic cell will do? Then electrochemical cell we will come. In electrolytic cell, what it will do? It will converts. If I talk about electrolytic cell, basically electrolytic cell converts electrical energy into chemical energy. Next thing, Faraday's law. So the next thing in electrochemical cell, whatever the things happening, it will follows Faraday's law of electrolysis. Faraday's law of electrolysis. In Faraday's law, what is the formula? W is equal to Z into I into T, or else Z is nothing but Z is molar mass upon N factor into 96,500 into I into T. We can rewrite this formula like this, right? So when it comes to Faraday's second law, what is the another formula we know? W1 by E1 will be equal to W2 by E2 will be equal to W2 upon E3, right? When different electrolytic cell are connected in series. When different electrolytic cell are connected in series. So if I talk about, this is first law, this is second law. Then next thing, when I am doing Faraday law of electrolysis, in cathode what we will be getting, in anode what we will be getting. For that I am just going to give one simple tabular column. Please do remember that. That's all, just direct tabular column, you know. That is product of electrolysis. Product of electrolysis. Basically, what will be the order of discharge potential? Greater the discharge potential, it has greater tendency to go and deposit at cathode or at anode. Whether it is gas means it will get evolved, solid means it will get deposited. So when it comes to order of discharge potential, if I particularly talks about cathode and then anode. If I talk about cathode, what will be the order is Au3 plus is greater than Ag, Ag plus will be greater than Cu2 plus, then Cu2 plus will have greater potential than Zn2 plus, then water. After water, we will be having Al3 plus. Then after Al3 plus, we will be having Mg2 plus, then Na plus, last is lithium. Now, when it comes to anode, please do remember SO4 2 minus is having very less discharge potential than NO3 minus, then H2O, then we will be having Cl minus, Br minus, I minus. Sir, how to do this? Very simple. Now, I will give some general idea. If I am having aqueous NaCl, imagine you are having one container. I am having one container. Inside this, what are all the ions will be there? Since I am using the word aqueous NaCl, okay, so not only for Ammu, whoever the students asking me for the 11th and 12th inorganic chemistry, do one thing. In the same channel, PW NEET English, I was doing the strategy video. P block in 8 minutes, D block in 8 minutes, thermodynamics in 8 minutes. Today, I am just going to give F block in 8 minutes. Already periodic trend, properties in 5 minutes. All the videos, all inorganic chemistry, I am doing as a 5-minute series. Go and watch those videos. That is more than sufficient. You guys can just go and watch. When I'm talking, only take screenshot also, because I will be moving away from the board. That is the time I'm giving for you guys to take the screenshot in those strategy video. Make use of it. Don't be selfish, forward to your friends also. That is also important. Yes. So if I'm dealing aqueous NaCl, what are the things will be there in the container? Na plus ion, Cl minus ion. Aqueous, that means H plus will be there, OH minus will be there. Now it is very simple. Look at this order. Anion, Cl minus, OH minus. Which one will move faster? Cl minus or OH minus? Which one will move faster? We know very well. Cl minus, actually what it will do? It will move faster than water. So Cl minus will move towards, anion will move towards anode because it is positive charge. Now cation, Na plus H plus, which one will move faster? Water will move faster than Na plus. So H plus will move towards cathode, negative charge. Now what will happen? In cathode, reduction will happen. So automatically in cathode, hydrogen gas will be produced. In anode, chlorine gas will be produced. Everybody getting an idea? So if we remember this order, automatically, easily we can able to do. It is clear, right? So this is very, very important, my dear students. Then, so automatically you guys can able to do it. But what is the condition? Electrode should be inert electrode. Electrode should not take part in a chemical reaction. That is, electrode should be, electrode nature should be inert. Electrode nature should be inert. That is very, very important. It is clear. Anybody is having any doubts? Now, these are all the things very, very important when it comes to electrolytic cell. Now, the next thing, what we are having? Electrochemical cell. Now, we are having electrochemical cell. electrochemical cell. Remember one thing, in electrochemical cell, what will happen? It converts chemical energy into electrical energy. It converts chemical energy into electrical energy. So how to calculate E naught cell value? Remember the formula. Standard EMF of the cell will be equal to E naught of cathode minus E naught of anode. Standard cell potential means we need to consider only reduction potential. Even in the part 1 class of marathon, 10 hours marathon in live session in the same channel, I told one thing to remember easily. If reduction potential value is more, the particular element has the greater tendency to undergo reduction, so it will act as a oxidizing agent, or else oxidizing power increases. So how to convert reduction potential, oxidation potential? Very simple. Magnitude wise, SRP value will be equal to magnitude of oxidation potential. Only sign convention. Negative SRP means positive SRP. If positive SRP means negative SOP. Why? Once again. Not SRP. Negative SRP means positive SOP, positive SRP. Why? Why, sir, this value you are telling actually? The main thing is what? We need to understand only one thing. If magnitude wise value is same, but we need to consider only reduction potential value according to IUPAC convention. If the question paper setter given SOP value, whatever the value given, keep the same value, change the sign. That is only reduction potential. It is clear? Hemant. Hi, Hemant. It is clear? So this is very, very important. Converts chemical energy into electrical energy. Done? It is clear? Then instead of standard EMF of the cell, if I want to calculate EMF of the cell at normal condition, then what is the formula we will use? We will be using Nernst equation. We will be using Nernst equation. So what is the formula? E cell is equal to E naught cell minus 0.0591 divided by N into log QC. What is QC? QC will be equal to Kc. If it is in equilibrium, QC will be lesser than Kc. Then forward reaction favors. If QC value is greater than Kc, then backward reaction favors. So all these things very, very important. Now maximum work done. What is the relation we can take? We can use this formula. Minus delta G naught is equal to NF E naught of cell. Otherwise, minus delta G is equal to NFE. When I will be using this, I will be using this formula when maximum electrical work done. In that case, I will be taking standard Gibbs free energy change. If I want to calculate only electrical work done, if I want to calculate only electrical work done, then I will be using this particular formula. It is clear? Then automatically resistance formula. What is the formula for resistance? R is equal to rho into L by A, resistance. Then mainly conductance, all those things we can able to write, resistivity, conductivity, everything we can able to write here. One more thing, molar conductance at any concentration, kappa into 1000 upon molarity. Equivalent conductance at any concentration, kappa into 1000 upon normality. Apart from this, for strong electrolyte, what exactly we know? for strong electrolyte at any concentration is equal to molar conductance at infinite dilution minus B upon root C. Right? Molar conductivity at any concentration is equal to infinite dilution minus B upon root C. So for strong electrolyte, how the graph will be like this? For strong electrolyte, for weak electrolyte, the graph will be like this. For strong electrolyte, what we know, alpha value is equal to 1. This will be, alpha value will be between lesser than or equal to 0.05. Partial dissociation. So these things are very, very important. Now we know very well Kohlrausch law. Yes, how to find out Kohlrausch law at infinite dilution? Very simple. So at infinite dilution is equal to not infinite dilution, everything is same. We can represent in any way. So is equal to kappa into 1000 upon solubility. How to find out solubility? From solubility product, x to the power x into y to the power y, s to the power x plus y. With the help of that, we can able to find out this. Instead of solubility, any other formula is there? Simply we can able to add, for example, lambda infinity m of ax by salt. How we can able to write? Lambda infinity of x a. I will write like this, lambda infinity of ay plus lambda infinity molar conductivity of y, once again ax by salt. So how it will get dissociated? X into lambda infinity of m x a y plus y into lambda infinity m of bx minus. If suppose I am writing for equivalent conductivity, what is the difference we can able to write? Equivalent conductivity means equivalent conductivity of ay plus equivalent conductivity of bx minus. What is the difference you guys can able to understand here? Remember one thing, whenever I'm dealing with equivalent conductivity, we won't consider the stoichiometric coefficient. When it comes to molar conductivity, we will consider the stoichiometric coefficient. It is clear? It is clear, my dear students. So this is all about electrochemistry. Only these two pages. Only these two pages. Please do make a note. Take a screenshot of this particular page, quick. Done. In the same way, take a screenshot of this particular page. So this is all about the complete electrochemistry. So as I told in the class, what we discussed, complete formulas we discussed for complete physical chemistry chapter. Now, what is your responsibility? Very simple. First, download the class notes. Class notes will be shared in the WhatsApp group. I believe everyone will be there in the WhatsApp, right? Or else in the description, even you guys can see our WhatsApp channel link. So first, enroll in WhatsApp. Automatically, you people will get the notes. Revise the notes. Why today notes is very important means I discussed all the formulas in physical chemistry. All the formulas. So in the last minute, please don't waste time. Revise all the formulas. Whatever the subtopics I given, please do focus only on those subtopics related numericals. Now, equilibrium, thermodynamics, redox. Don't forget part 1 of marathon. 10 hours marathon. If you watch that, you will get for inorganic chemistry. Just follow our strategy video. In 5 minutes, I'm giving all the details, exceptions with respect to inorganic chemistry. Okay, it is fine. So now your duty is to revise all the formulas and try to solve more and more question. Okay, so solve question. Now, since I given the formula sheet in today class, in the next class onwards, physical chemistry means what I will do? I will solve only question, because now you people are having complete formula sheet of Prithviraj Sir. It is fine. Done. So download the class notes, practice more and more question. With this, I am finishing today class. Yes, thank you so much, sir, for your effort. My effort is only for you guys. Make use of these things. Download the formula sheet. Try to solve question. Even I will do in the next class onwards. For inorganic chemistry, stick to our channel strategy video. There I am discussing each and every inorganic chemistry tricks, trend, exception in less than 5 minutes. That is very, very sufficient, more than sufficient. Okay. Okay, my dear students. Take care. Bye-bye. See you in next class.